Hello students, welcome to my channel Explore Physics, Let's Explore. In the previous classes, I've solved few numerical problems based on series and parallel connections. Today, I'm going to solve few numerical problems based on combination of resistors, that is, combination of series and parallel connections. So without further delay, let's start the class. This side, as you know, this side the numerical problems will be displayed for you, and here I'm going to solve those problems. So let's start with the very first numerical. The first one is, show how you would connect three resistors, each of resistance is 6 ohms, so that the combination has a resistance of 1 9 ohm and 2 4 ohm. So three resistors are given to you. Say R1 is equal to R2 is equal to R3, and all are of 6 ohms. In first case 9 ohm, and in second case it should be 4 ohm, right? Yes. So let's take the example where we have connected two resistors in parallel and one in series. So each is for 6 ohm. This is also is for 6 ohms. So we'll see what will happen. So for first case, when they both are in 6 ohms, they both are in parallel connections. So the resultant will be 1 upon 6 plus 1 upon 6. So the parallel, because these two are in parallel, so we'll be finding the resultant first for these two parallel connections, and whatever the result is, that will be in series connection with the third 6 ohms. So 1 upon R is equal to 1 upon 6 plus 1 upon 6 parallel connections formula we had taken, and that will be 2 upon 6, that is 1 by 3. Therefore, R will be equal to 3 ohm. 1 R is equal to 1 upon 3, so R is equal to 3 ohms. So I can make the equivalent resistor, this thing. So now my connection will be 1 3 ohm resistor, and with that 1 6 ohm resistor is connected. So what will be the total resistance? 6 plus 3 9. So I'm writing it here. So what will be the, when these are in combination, so here I'm writing the R, resultant R will be 3 plus 6, that is 9 ohm. So we have 9 ohm in one case, the resultant, the net resistance, where first two 6 ohms are connected in parallel and one in series. So the resultant is 9 ohm, that is the first part. Yeah, they wanted 9 ohm. So this is the case how we are going to, join them together. Now the second case, so now we have one more option left where I can show that two are in series and across that one is in parallel. So I'll show the diagram and then it will be clear to you. So the next option what I can have, when two are in series and one is in parallel with that. So this is 6 ohm, 6 ohm each we have been given. So first for them it will be 6 plus 6, that is 12 ohm, right? And now this 12 ohm, the equivalent resistance is, now this 12 ohm is in parallel with 6 ohm. So what will happen, we'll see. So now 1 upon R, the resultant will be 1 upon 12 plus 1 upon 6 equals to, I'm writing it here, giving the little space because this thing should be clear to you, the diagram. So this will be 12, 1 plus 2, that is 3 by 12. So 1 upon R is equal to 3 by 12, that is 1 upon 4. That implies R is equal to 4 ohm. That is what the second part says. Yeah. So we have R is equal to 4 ohm, And the combination will be this, that in the second case when we have to get the net result resistor as 4 ohm, net resistance as 4 ohm. So in that case the two resistors of 6 ohm each will be in series, and across that one will be in parallel. So that is the solution for first case. As I told you before also, please keep on practicing the numericals. More practice will make you perfect. Always remember, I've told you before also, again I'm reminding you, never forget to write the unit. R is equal to 4 ohm. So you have to write OHMO or the omega symbol. That is the solution for first question. Now we are going to take the second question. The second question asks, a hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately, in series or in parallel. What are the currents in the three cases? So actually it's not like combination, because we have to find first the independent resistor, that is separately, then in series, and then in parallel. So all three are used in that, but it's not a combination of resistors as such. So what all is given to you? V is equal to 220 volts and RA is equal to RB is equal to 24 ohms. What are the currents in these three cases? So you have to find I. In these three cases means separately you have to find. First case when it is individually connected. So from Ohm's law, V is equal to IR. So I is equal to V by R. V is given to you as 220. Right now 220 was given to you. Yeah. And R is given to it 24. So it will be equal to 5, 4, 6 are 24, 4, 5 are 20, 4, 5 are 20. 55 by 6 equals to 9, 6 are 54, and 9 ones are 9, and 6 ampere. 9.16 ampere. In the first case when coil is individually connected. In the second case it's given series first or in series. So I'll write in series when they were connected in series. So what will be the R first? What will be R? R net resistance when they are connected in series will be 24 plus 24, that is 48 ohm. So I will be equal to V upon R, 220 upon 48. So again if I am going to 4 ones are 4, 4 2s are 8, here 55. So it will be 55 upon 12. So 12 4s are 48. 4.58 ampere will be your current when they are connected in series. Now third, when they are connected in parallel, you have to find. So in the third case, when they are connected in parallel, so 1 upon Rp will be equal to 1 upon 24 plus 1 upon 24 equals to 2 upon 24 is equal to 1 upon 12. So Rp will be equal to 12 ohm. 12 ohm, correct? No? Yeah. So that will be 12 ohm, and from here I am going to find I again. So I in third case will be equal to again V by R. V was 220, R was 12. So again 4 3s are 12, 55. So it will be 55 by 3 equals to, therefore I is equal to 3, ones are 3, 18.33 amperes. So in all the three cases we found the current. One, when it is individually connected, each of the coil, whether it is RA and RB, because they both have equal resistance. Then second case, when they are connected in series, so the net resistance will be R1 plus R2, that is 24 plus 24, 48 ohm. And in third case, when these two coils are connected in parallel, so 1 upon Rp will be 1 upon 24 plus 1 upon 24, or Rp will be equal to 12 ohm. You put in the formula is equal to V by R, and you'll get I is equal to 18.33 amperes. That is the solution for second question. It's not the combination, but you have to find all the three currents in three different cases. So that was the second question. Now I'm going to take up the third question and we'll see what does it say. So the third question says, please subscribe and like my channel if you like the content. In the circuit diagram given below, find total resistance of the circuit, total current flowing in the circuit, and the potential difference across R1. So we have been given one circuit. Okay. Yeah. So this is the circuit. You can see it here. This side is given to you, where this is R1, 7.2 ohm is given. R2 is given as 8 ohm. This is R2 given as 8 ohms. And this is R3 given as 12 ohm. The voltage is given as 6 volts. What do you have to find? Total resistance. You have to find total resistance R of the circuit. The second is you have to find total current flowing in the circuit. And third, you have to find potential difference across R1. So VR1. You have to find all these three things. Okay, we'll do it. So we'll refer it one by one. So first, total resistance. See, R1 is connected in series with the combination of these two. So first I'm going to find the resultant or the net resistance of these two resistors which are in parallel to each other. You can see these two, 8 ohm and 12 ohm, are in parallel to each other. So first I'm going to take find the resultant of these two resistors. Then whatever it comes, that will be in series. That will be my total resistance of the circuit. So first we'll see resultant will be equal to 1 upon R2 plus 1 upon R3. What is R2? 1 upon 8 plus 1 upon R3 is 1 upon 12. Correct? So it will be equal to 24. 8 3 is 24 plus 2. So that is equal to 1 upon R will be equal to 5 by 24. So is equal to, or that implies R is equal to 24 by 5. So it will be equal to 5 4 the 4.8 ohm. That is the resistance of these two these two parallel resistances. Now total R, say I'm just finding it as RP, you can say. This was RP. So now the total resistance will be equal to, because R1 and RP, they are in R1 plus RP, because they are in series. So R1 was 7.2 plus RP we found is a 4.8. So this will be equal to 8 to 10, 31, 8 and 4, 12. So that will be 12 ohm. So this will be equal to 12 ohm. So the net resistor of the resistance of the circuit is 12 ohm. So the total resistance is 12 ohm. What did we do? We first found the resultant of these two parallel resistors, and then that will be added to R1, because R1, and we named it as RP. So R1 and RP, because they are in series, so that will add up. So that we get 12 ohm. The total resistance of the circuit is 12 ohm. Clear? The second part of the question is, total current flowing in the circuit. So the second is I is equal to V by R. V is given as 6, R we found 12, so is equal to 1 upon 2 is equal to 0.5 ampere. Simple. So I will be equal to, simple for from Ohm's law, V is equal to IR, so I is equal to V by R. V was given to you the 6 volt. R is, we found R as 12. So 1 upon 2, that is 0.5 amperes, right? Now the third part, you'll see whether it is potential difference across R1. So potential difference across R1, V is equal to I, R. I we found 0.5. R is, R1 they have to find. R1 is 7.2. So this will be equal to, therefore VR1 will be equal to 3.6. So that is 3.6 volt is the potential difference across R1, across 7.2 ohms resistor. That is what we have to find. Yeah, the potential difference across R1. So 3.6 volt, correct, is the potential difference across R1, resistor R1. So that's all about the combination of resistors. There are so many numericals. So as I told you before, please keep on practicing. Make your own circuit, children. Randomly you pick up few, assume that 2 are in series or 1 in parallel, like this. You can make your circuit, try to solve it to just make it more perfect. Okay, stay safe, stay healthy, and keep liking my channel. Bye bye.